Hello, this is Ms. Schultz. Hi, so this is a video for pre-calculus here at Boston Collegiate, and this is our second topic of the year under our first unit, features of functions. So I'm going to go over function notation and compositions. Today you'll be familiar with this, with some things, but we'll get more abstract than you ever have before. So function notation, so X is the input, and then Y is the output. So Y and f of X are both equivalent, so these are both outputs. And f is the name of the function. So you could name the function f, you could name it g of x, you could name it h of x. So instead of having y being three different things, that doesn't make sense. How can three different things equal the same thing, y? That doesn't make sense. To have y equals 2x and y equals 2x plus 1, how can those both be equivalent to the same thing? That doesn't make any sense. So they would be equal to different things. So say like f of x, and then this is a different function, so you give it a different name. So that's the point of function notation. And just whatever's inside the parentheses is your input. And then f of x slash y are your outputs. Okay, so compositions of functions, this is one of the two notations, f of g of x. So if you see here, previously I said what's in the parentheses is the input, right? So here, x is the input, it's inside the parentheses. But wait a minute, there's another set of parentheses. So g of x is also an input. So what does this mean? I think of it like a little function machine here. The innermost function is g, so it's kind of like when you learn PEMDAS, you go from the inside of the parentheses outward. So you start with x and you put it inside the function, I mean substitute it into g first. So x goes into g, and then maybe the function is like multiply by 2, add 1. And then so you come out with an output, a different number probably. And then you take that, the output to g becomes the input to f. So the output here becomes the input to f. Yeah. And then you input it to f, which might be, I don't know, divide by 7. And then you take that output and you divide it by 7, and then you get your final output, which is f of g of x. Okay? So here's that explained in words, just what I said in words. So take a second. Let's read it together. Yeah. Composition of functions means the output from the inner function, in this case it's g, right, becomes the input of the outer function. So for example, f of g of 3 means you evaluate the function g, so your inner guy first, at 3. Then, and you get a value. Like it's probably different, it's probably not 3. Then you substitute that value into the function f in place of the x, okay? This is a big notation, so this little like degree sign, but it's just in the middle of it, is a big notation. And having taught this before, I'll say this is where students will trip up just because they don't know what this means. You also don't need to put these parentheses here. So f of g of x, almost every time you see this, I encourage you every time you see this to just rewrite it, f of g of x, because you're used to multiple sets of parentheses embedded inside each other from learning PEMDAS. So this is more familiar to tell you to go from the inside out. So this means composition of functions, relate it like that. And composition means an output of one becomes the input of the other. That's the definition. Okay. Okay, so that was words. I explained it with words. Now we're going to do composition of functions numerically. Just to recall what NA means. NA stands for graphic, numeric, algebraic, and words. Okay, and so here's the big idea of our whole course, which you've already been introduced to. Changing to an equivalent representation can create access to a problem. Same value, different form. So you can see this example of a square root function represented graphically, numerically, algebraically, and with words. So That's our big idea of the whole class. That's the glue that's going to meld everything together. It's our American dream, if you will, for math class. Okay, so let's do this one together. Numerically. So find h of g of 1. So you can see that I have 4 different functions with different names. So this is function f, g, h, j. So here I'm going to find g of 1 first. So g of 1 is 8. So that output of 8 becomes my input to the outer function. So g of 1 is 8. This is because g of 1 equals 8. Which is right, I go to the G, table, and I go down to 1 on X, and I read over that G of 1 is 8. So now I need to find H of 8, so go to the H table, okay? Go to the H table and find H of 8, which is 7. So that's my answer, okay? A common mistake would be like if this had an input of 1, like you don't just go straight to H, right? You have to do it in this like inside out order. Okay, so now I want you to on your own find f of h of 4. Okay, so you're gonna have to find f of h of 4. All right, and we're back. So you evaluate from the inside first. H of 4 is 3. So again, I did that by using the H table, so I have to choose between the tables. I go 4 over 3, and then now H of 4 is 3, so I replace H of 4 with 3. So F of 3 is 0. So that's the correct answer. Keep in mind I could have written this with the alternate notation of F of H of 4, and that would have been equivalent. All right? So here, you've already learned about domain and range, so why don't you practice with what's the domain of f of x? So this is f of x, this is g of x. I don't think it's labeled, but that's g of x. So 1 through 5, it's just referring to up here. So please take a second and state the domain of f of x and the range of f of x, please, this graph. Alrighty, and we're back. So the domain, so I noticed that there's no arrows, so it starts at -5 and it's a closed circle. So -5, there's no breaks in the x values all the way till 5. Okay, you could have written that with inequality notation 2, which is totally cool. What's the range of f of x? The lowest y value is -2. It does equal -2, and then you go up to 2, and there's no y values, it skips. And again, you could have written that in inequality form. This could have also said f of x instead of y. Okay, so find f of 3. So just like the numerically, so 3 is my x value, f of 3 is the y value. So this is basically saying there's a point on the graph, 3 comma question mark. What's that question mark? It is -2. So you go to negative, so this is just saying what's the y value at x equals 3? What's the y value at x equals 3? -2. Numbers 4 and 5 are a little trickier. So name the values that satisfy f of x equals 0. So this is basically y equals 0. So the y is 0, and I want you to give me the x values now. See how it's the opposite from number 3? So the y's are 0 right here, and right here. That is where f of x equals 0, or in other words, y equals 0. So this is, I notice the slope is 4, so this is exactly halfway, so it will be a half. So -4.5, 0, and +4.5. If I wanted to write x equals, I could, but those are my answers, okay? Name the values. I'm just going to erase a little bit here to clear it out visually. F of x equals -2. So this is like a little bit different from number 5, so I'm going to do this with you as well. So f of x equals -2. This is the same as y equals -2. So it's asking At what x values does y equal -2? So let's go here. Y equals -2 is here. You can think of that really as a vertical line, or horizontal line rather. And where's that horizontal line intersect with my graph of f? Right here, boom. So that's at -6. Is that -4.5? Yeah, okay, so this is -5. I'll write x equals just to be clear about what I'm doing. So x equals -5. Where else does it hit? And then it hits in this whole range. So what would be wrong would just be to say like 1 and 4. That would be wrong. Wrong, okay? It's everything from 1 to 4, okay? So I'm gonna do that. So it's at -5 and then from 1 to 4. There's different notations where you could use a little u for, yeah, I think we'll just use that notation. Okay, so next problem, you're gonna do this one on your own using this G graph. It's like number 4, number 5. What are the x values for g of x equals 1? So g of x equals, what are the x values for g of x equals 1? Go ahead and try that, please. Okay, so g of x equals 1 is like y, we're back, is like y equals 1. So is this like horizontal line here? It's where does that intersect? The first thing I say is that there's 3 answers, 3 discrete answers, not like a domain. It's not like number 5, this is more like number 4. So it, the x value -2 is a solution. Right here, 0. And then it's very symmetric, so at 2. Okay, so those are my solutions there, because that's where it hits, where g of x equals 1. In other words, my output is 1 at these 3 inputs. So I could also write this as like g of -2 equals 1, for instance. G of 0 equals 1. Okay, so these are my different x values where it equals 1. Okay, so now we're on to the algebraic. So we did words first, talked to you about what it was. Then we did numeric. Numeric means tables, is the most common way to see numeric in our class. So we did words, we did numeric, then we just did graphs. Now we're doing algebraic. The rest of this, sorry about that. The rest of this PowerPoint will stay on algebraic. So here, even if you think of this right on top of each other, so my x is -2. Let's take a look at this. It says find f of -2 if you're given f of x equals this. So this means that x equals -2. So you want to substitute -2 in for x. Every time we substitute, so f of -2 equals, every time we substitute, we just do it in parentheses. Don't forget that. So 2 times -2 squared minus 3 times -2 plus 6, all right? So I will let you chomp on that and come up with the final numerical answer. All right, let's come back. So this is -2 squared is 4. -2 times -2, this would be a positive 6, right? So 8 plus 6 plus 6, so I like 8 plus 12, which is a nice 20. So f of -2 equals 20, all right? Okay, so you've likely done something like that before, but this is where it gets advanced, pre-calc-y. So I'm substituting in a variable. So I'm replacing one variable with a different variable. I'm replacing x with 2k. So this is more abstract, still algebraic though. Algebraic means I'm given an equation. Basically, that's what algebraic means. My function's not graphed, I don't have a table of my function, I have an equation of my function. That's what algebraic means. Okay, so f of 2k equals, and then, so I want you to substitute 2k everywhere you see an x. Try that. Okay, hopefully you did it in parentheses. Squared minus 3 times 2k plus 6. All right, now let's do this out. So this is 2 times 2k squared. You have to square both things in the inside. So 2 squared is 4, k squared is k squared. Or in other words, this is 2k times 2k. Okay, so this would be minus 6k plus 6. F of 2k is equal to 8k squared minus 6k plus 6. All right, so this is, the next two are going to be the same concept, but a little bit harder, where you're substituting a variable. You're replacing one variable with a different variable. So here you're replacing x with the 2k. All right? So notice how this one, when you substitute a number, you're going to get a number as an answer. When you substitute in a variable, you'll get variables as your answer. You know, some people think, wait, is that like my answer? Yes, that's my answer. It's cool. All right, so we're going to do these 2 slides and then stop, but that's going to, you know, take a little bit. So here, I notice my x, I'm replacing it with x plus h. I think this is even more confusing than the last example, because in the last example, x and k are different letters, right? X and k are different letters, so substituting it felt sort of okay. But here, I'm replacing x with x plus h. We notice that x is sort of like similar to x plus h, and that they both have x's, but it's cool, okay? So for a strategy for substitution, I like to sort of put in parentheses to start with when it gets tricky like this. Everything I'm going to substitute for. So I'm going to substitute for all the x's. There's only one, so I make one substitution. If there were more x's, then I would substitute again. That can totally happen. Okay, so f of x plus h equals, so see how my x becomes x plus h for when I just write what I'm trying to find? So that happens here too. X becomes x plus h. Okay. Let's do it out. I mean, this is let's do this out to fully simplify it. So go ahead, just distribute that 2. 2x plus 2h plus 7. That is my answer. I do not have any like terms that I can combine. All right, let's move on to the second one. So I'm doing the same thing. F of x. So my x is becoming x plus h. I'm just even going to write it right below it. X plus h, just to make my x is becoming x plus h. So I'm going to go through my function, given as an equation algebraically, and I'm going to just put parentheses around every x. Not every variable, but every x, because it's the x's that I'm replacing. Right? Cool. So now I will leave it to you to please make that substitution, and then if there's any like terms, combine them at the end. All right, let's come back together. So 1 over 3, I'm going to replace the x with x plus h, and then the h just stays. It's just chilling. It could have been an 8 instead of an h, like that's, you know, it's just there. So I'm going to distribute this out. So 1 over 3x plus 3h minus h. I'm going to see if there are any like terms. Aha! There are. Equals, I'm just going to write it here. So let's just say like f of x plus h equals, so this is 1 over, let me make sure you can read it, yeah, 1 over 3x, and then 3h minus h is 2h. Okay. So the big thing is if you're given f of x, you replace all the x's with whatever, you know, it's telling you to, okay? Whoa. All right, this is a classic example. You'll see this form a lot, so let's just take a step and look for it. This is our last slide. But this is a meaty example, all right? And then tomorrow in class, we're going to start right in on this. Okay, so you're going to evaluate f of x plus h minus f of x all over h. Okay, so here I notice, here in this problem, there is one f. So I substituted in, you know, just the one big time. Here, one f. Here I notice that there's 2 different f's. So I'm going to use the function named f twice, right? Peace out. Okay, so I'm going to start there. So I'm gonna just like, first of all, think of this as some mini problems on its own. I'm gonna think of it as this piece, and then a little h on the bottom, okay? So just like to get our you know, bearings, I'm gonna just do as scratch work. It may help to do it every time. Maybe it'd be too confusing, but I'm gonna do it this first time. I'm gonna do f of x plus h on this side here. So everywhere there's an x, that's where I'm gonna make my substitution. There's one x, so I will make one substitution. X plus h squared. So that's what f of x plus h is. And then and then minus f of x. What is f of x? Well, f of x, I would like basically replace this x with that x, so it's the same. It like literally just tells us f of x is x squared. Boom. And what's h? Remember, you don't substitute for anything. You don't substitute for h's. Okay, so f of x plus h is x plus h squared minus f of x is x squared. I'm gonna put that in parentheses just to model that we are substituting, and it won't make, okay, I'll go back there in a second, but I'm just gonna put it in parentheses for now. Okay, so I did f of x plus h, this corresponds to that, minus, this corresponds to that, and then the h, just chilling on the bottom. There's nothing to substitute for because there's no f with an input in parentheses. So here's why I put this in parentheses before I move on, is because if this had multiple terms, I need to make sure the parenthesis, the subtraction sign, is gonna get distributed. I need to make sure of that. So always put your second term in parentheses and it'll catch mistakes for you. Okay, so let's do this out. What would be wrong? I'm going to do what's wrong. X squared plus h squared. The exponents do not distribute over addition. They do not. They do, in fact, distribute over multiplication. Like this distributes. See how that's multiplication there? They do distribute over multiplication. They absolutely do not distribute over addition. So let's actually show out what squared means. X plus h times x plus h, like that. That would be squared. Minus, at this point I'm distributing the negative, but there's only one term, so it's not really a thing. All right, and then I'm gonna keep going. Just like here, see how I multiplied out the 3? And there did actually happen to be 2 like terms, so this did end up being more simple. I'm gonna see if that happens here too. Spoiler alert, it does. There's gonna be some like terms that combine. Okay, so I'm gonna do distribute the first x squared to both of these terms, plus xh, and then plus, because that's positive, h times x is hx, but I'm just going to write that as xh, and then h times h is h squared. So that's this, okay? So if I'm still keeping track of my buckets, that's that. And then my second term is just still x squared all over h. So I want you to please simplify that on your own. Go ahead. Like simplify it fully. Well, as much as you can. Okay. So we're back. Let's see. So here's what I notice. I notice that this x squared cancels with that x squared. So that's your next step. Okay, so the next step would be, I'm gonna move horizontally now. The next step, let's see, would be those subtract to 0. xh plus xh is 2xh. So 2xh plus h squared all over h. You can simplify this further. Cool, sweet. You can simplify this further. So there's 2 ways to think about this. You could think of the h divide. How do I know that I can simplify this further? Because 1, 2, 3, I have 3 terms, and every term has a common factor of h. Every term. Sweet. So you can think of it as what's like, so method 1 would be like what's 2xh over h plus h squared over h. You could think of it like that. Just like they're both being divided by h. Or you could think of it as factoring. So I'm going to think of them as they're both being divided by h. So that cancels to 1. That makes a fancy 1, right? Fancy 1. Yes. And then h squared over h is h. That's my final answer. But the other way to do it, method 2, method 2 is actually the way I see it, but I'm a math teacher and I'm like big into factoring, so maybe that's just me. But method 2 would be to factor the numerator. H is a common factor that factors out. So 2x plus h over h. All right, and then here's my fancy one. That's my fancy one that cancels. And again, so I'm left with 2x plus h. Boom. So that is my final answer. All right, this is Michelle signing off. Hopefully, yeah, let me know any questions when you next see me, probably in class. Bye.